Uranium, the most powerful and dangerous metal on Earth. It can light up entire cities. It can power submarines for years without refueling. It can treat cancer and save human lives. And in the wrong hands, it can erase a civilization in seconds. This is uranium, and right now it sits at the center of one of the most intense geopolitical standoffs on the planet. In recent talks held in Islamabad, the United States presented Iran with a set of firm conditions. And at the top of that list was a demand to halt uranium enrichment and surrender its existing stockpiles. But why is the United States so deeply concerned about uranium? What makes this single metal so powerful that world superpowers are willing to go to the edge of conflict over it? Today, Farground takes you inside the full story of uranium, from its discovery deep in the earth to its role in shaping the future of global power. Uranium is element number 92 on the periodic table. It is one of the heaviest naturally occurring metals ever found on Earth. Dense, radioactive, and unlike anything else in nature. It was first discovered in 1789 by German chemist Martin Heinrich Klaproth, who identified it inside a mineral called pitchblende. At the time, no one truly understood what they had found. It would take more than a century for the world to realize just how extraordinary and how dangerous this element really was. Naturally occurring uranium contains two primary isotopes. The first is uranium-238, which makes up roughly 99% of all natural uranium. The second is uranium-235. And this is where everything changes. Uranium-235 is the isotope capable of sustaining a nuclear chain reaction. It is the fuel behind nuclear power plants, and it is the core ingredient of a nuclear weapon. The most significant and widespread use of uranium today is in nuclear power generation. Inside a nuclear reactor, uranium atoms are split in a process called fission. This splitting releases an extraordinary amount of heat energy. That heat boils water into steam, and that steam spins turbines to generate electricity, clean, consistent, and incredibly powerful. To put the scale into perspective, just 1 kilogram of uranium produces the same amount of energy as approximately 1,500 tons of coal. No other fuel source on Earth comes close to that kind of energy density. Beyond power generation, uranium plays a critical role in modern medicine. Radioactive isotopes derived from uranium are actively used in diagnostic imaging, helping doctors detect diseases at early stages. They are also used in targeted cancer therapies, where radiation is directed precisely at tumors to destroy them while minimizing damage to surrounding healthy tissue. In research laboratories across the world, uranium is also studied for its unique physical and chemical properties, contributing to advances in material science, engineering, and physics. Because of its extreme density, depleted uranium is used to manufacture armor-piercing ammunition and reinforced military vehicle plating, making it one of the hardest and most effective materials for absorbing and deflecting high-velocity impact. Nuclear-powered submarines and aircraft carriers use enriched uranium as their fuel source, allowing these vessels to operate for years without ever needing to refuel. They can travel anywhere in the world's oceans silently, quickly, and without stopping, giving nations with nuclear-powered fleets a massive and undeniable strategic advantage. And then there is the nuclear weapon itself. When uranium-235 is enriched to weapons-grade levels and brought together in a precise configuration, the chain reaction becomes uncontrolled, releasing energy in a single, catastrophic moment. The bombs dropped on Hiroshima and Nagasaki in 1945 demonstrated to the world exactly what that means. The destruction was total. The consequences lasted generations. Uranium does not come without a price. Mining uranium is an extraordinarily dangerous process. Workers exposed to uranium dust and radiation over long periods face severe health risks, including kidney damage, radiation poisoning, and significantly elevated risks of cancer. Communities living near uranium mines have reported alarming rates of illness and environmental contamination that persists for decades. When uranium waste is mishandled or improperly stored, it becomes a long-term environmental disaster. Its radioactive decay continues for thousands of years, meaning a single act of negligence today can poison land and water supplies for generations to come. This is precisely why uranium is one of the most tightly regulated materials on Earth. The International Atomic Energy Agency, the IAEA, monitors uranium stockpiles, enrichment programs, and nuclear facilities around the world. The goal is simple: ensure that uranium is used for energy and medicine, not weapons. But as we see in current global tensions, that goal is not always easy to enforce.